they're not going to take action unless they get secondary or even third or fourth confirmation that this thing is actually occurring. So what we want is for people to take action as soon as we tell them. And in order for that to happen is that they have to hear and know that this is real. This is not, oh, is this just a test? No, this is real. All right, the tornado sirens are going off, and it's real. And so then they'll take action and protect their life. And that's really what we want them to do. Also mentioned it enhances our warnings. And then the third thing it does is it helps neighbors downstream. Right? You see something here around Effingham or wherever you live, people east, northeast of you, southeast of you, they need that information. They're like, oh, this storm has a history of producing a tornado. Hey, I need to take action because they're issuing a warning for that. So storm spotters, not chasers, but storm spotters are very important to the process of us doing that kind of stuff. Yeah, right? We'll move on. Okay. If you've done the class before, you know we used to put out and give out these spotter guides, right? Well, the Weather Service does not print these anymore. We've gone to digital, so they are online. You can find a link on that website, ilx.r/spotter, and you can get a copy of that in PDF format if you actually want one. We don't print them anymore because it costs too much money. We also have a handout. I have a table out there just to the right of the last door, or just to the right of that door over there, where the handout has got some information on it. It also has websites that you can link to or get to, so you don't have to write everything down that we go through here today. But that address is the same place, weather.gov/. You can find that online too. I'm not sure where it is anymore, but like I said, the spotter guide is online, and then that's out at the table. So as soon as this class is over, you can pick one of those up. We also have cloud charts out there, which are pretty cool. We've got lots of those, so please take one. And if you're a teacher, you can feel free to take enough for your class. All right, if there are any teachers here, any teachers? One. If you're a teacher, take some for your class. The whole class will love it. So here's what we're going to talk about in the first half. All right, we're going to talk about thunderstorms, development, moisture lift, what's required for a thunderstorm. We're going to talk about tornadoes, of course, because that's the big thing, and damaging winds and hail. We'll focus on that as well. Toward the end, we're going to have a break, about a 10 to 15 minute break, because I will definitely get done before the end of the session. All right, we're going to have a break. After the break, we're going to have a quiz. It'll be graded. All right, kind of a contest. So we're going to have a quiz. And then we're going to come back after the half and talk about some other stuff. So let's talk about thunderstorm development and some of the terminology that we use. All right, so for any thunderstorm, there's actually 4 ingredients that you need for a thunderstorm. You need moisture, lift, instability. Oh, on the light, you can't see that last one. The last one says shear, wind shear. That one determines how strong or severe the storm is going to be, the wind shear. But the other 3 are required for any thunderstorm, whether that's in January or July. Doesn't matter, you need that. So where do we get our moisture? Primarily we get our moisture from the Gulf of Mexico. It makes sense, right? Southerly winds brings in a lot of moisture, warmer air into the area, and then that's where we get a lot of our moisture. But we also get moisture from the vegetation. Not so much the trees or the grass, but I'm referring to corn and soybeans. There's a lot of soybean fields if you go north of here, a lot of corn and soybean fields if you go north of here, right? Or kind of west a little bit. Your hand, a few people, pretty humid, right? You kind of melt out there, right? Yeah, my brother almost died doing it. I didn't do it, so I'm smarter. There's a lot of moisture coming from the corn during the growing season, right? You're talking about July and August time frame. All that moisture that the corn soaks in, it re-releases back into the atmosphere during the evening hours and overnight. So that during the daytime, it's now more humid in the cornfield, but that humidity gets carried elsewhere. So the dew point, we like to talk about the dew point. The dew point, the higher dew points like upper 70s, low 80s, is coming from the cornfields and the soybean fields, not from the Gulf of Mexico. So some of our higher moisture days are because of the fields that are out here. And I'm not knocking farming, okay? God bless you guys that do the farming. It's very important, but we do get a lot of moisture, and sometimes our severe weather is more enhanced because of that extra moisture. Now you also need lift. Now that's anything like a front, some sort of a boundary, heating of the ground. As it heats up, air begins to rise. We know that. You boil water. What does the steam do? It goes up. So same concept. Fronts also push the air upwards, cold fronts, warm fronts. The jet stream also has an indirect effect of pulling the air up. And then there's also outflow boundaries from existing thunderstorms. And if you've taken the class before, you know that we talk about outflow boundaries from thunderstorms interacting with existing storms, making them stronger. So we look for outflow boundaries, and that's one of the things the radar helps us define is those outflow boundaries. Then you need instability. We're going to cover that. And then you need wind shear. No, you can't see that, but with the lights dimmer, you can. We're going to talk about wind shear as well and why that's important. So, third ingredient is instability. And what is that? What is instability? We talk about the air being unstable. And basically what that means is that once the air is lifted, what's the likelihood that it's going to continue rising on its own? Right? It's not being forced up anymore. The front comes in, pushes the air up, but this is an unstable atmosphere, so the air is going to continue rising. That's where you start to get your thunderstorms, and the faster that air rises, the stronger those thunderstorms can be. All right? So as the balloon that you see there, it's the same concept. The air inside the balloon, if it's warmer than the air outside the balloon, it's going to continue to rise. All right? And that's what instability is referring to. There's the temperature component of it and the moisture component, and that's what contributes to that instability. Okay? Warmer temperatures rises. If it's more moisture, it'll rise as well. How many have ridden on a balloon or seen a hot air balloon? You see how they fill them up, right? There's a lot of air in it. Go anywhere. Until they start putting in hot air, and they heat it up with those big burners. So that's how that works. There we go. Okay, so now you see how the clouds are going upward there. That's unstable atmosphere right there. The mountains are probably lifting some of the air because as the air pushes against the mountains, it'll rise. And then that air over the mountain there is unstable. And that's why you see that thunderstorm growing. Now, we do look at the atmosphere and see if it's stable. If the air is stable, then it's not going to go anywhere. The air is going to stay in one place. So let's say on a winter day when we have a lot of fog, that's usually a stable atmosphere because the air is either just sitting there or it's sinking. That's considered stable. Summertime, when we got air rising, you don't get a lot of fog, right? Pretty quickly during the morning hours. Let me try something. Okay, so that's stable air. So if there's stable air, we're not going to get the thunderstorms. And usually in the summertime, this is kind of what the clouds look like. They're kind of flat, kind of puffy, pretty clouds. That's a stable atmosphere. So why is instability, why is that important? Well, because every thunderstorm has what we call an updraft. And that updraft is coming from the fact that the air is unstable and that the air is rising. Warm, moist air will feed into the cloud, into the storm, okay, as it continues to rise. And as long as the air remains unstable, then that storm is going to continue to go. And then there's other factors that keep it going or causing it to die out or whatever like that. The precipitation in the cloud forms at the higher levels of the storm, and once that gets, and hail will form at the upper levels of the storm as well. Now, as far as severe weather is concerned, tornadoes are going to develop in that updraft area. All right, we'll get more into that when we talk about supercells, but you'll see that where the updraft region is, that's typically where you see your tornadoes develop, especially the stronger and longer lived tornadoes are going to be in that updraft region. Now, every thunderstorm also has a downdraft, all right? And that downdraft is once the air and the rain gets up there and possibly hail, there's going to be a time when that's going to start to come down as well. Every storm has both, an updraft and a downdraft. All right, so the downdraft is where you get your heavy rain, you get your high winds, you get your hail. That's that is as that colder air to the ground. And one of the things to know is that as that downdraft, as that air is coming down, it will increase in speed. There is that possibility it will increase in speed. It's stronger winds on the surface as it's coming down. So now what is instability? So we've talked about moisture lift and instability, but what is wind shear? Wind shear is either change in speed with or the change in direction with. Okay? Sorry, I'm cutting here for some reason. But change in speed with height or change in direction with height. And usually the speed is going to be increasing with height. All right? The direction could be any direction, but certain directional changes with height are more favorable for tornado development than it is for just a regular thunderstorm. All right? So wind shear is that change as you go up in elevation, as you go up in height. And that's important. The stronger the wind shear, the stronger the storm, the more likely it's going to produce some sort of severe weather. The weaker the wind shear, the shorter lived the storm is going to be. All right? So that's how you get the difference between a regular storm and a severe storm. So in this video that you see here, you're going to see wind shear. And what you're seeing is clouds moving at different directions at different elevations. That's what the shear is. That's showing you, that's a visual of what the shear looks like. So sometimes you'll get on the surface, winds will be out of the southeast, but then as you get up to maybe 5,000 feet, they're out of the south. You get to 10,000 feet, they're out of the west. And usually during severe weather days, the speed is going to be increasing as you go up as well. All right, and that plays a factor, as we'll see here in a minute, in the difference, the location of the downdraft relative to the updraft. Those two need to be separated, so to speak. All right, so this wind shear is important, and I was already talking about that, is because the wind shear, if it's weak, the updraft and downdraft are close together, which means the storm's going to last a short amount of time. Typical thunderstorms only last about 30 to 45 minutes, and that's because there's weaker wind shear. The updraft actually will collapse onto the the downdraft will collapse onto the updraft, and it just kind of cuts it off. So you're cutting off the airflow into the storm. You're cutting off the air into the engine or to the fire or whatever. You're cutting that off with the downdraft. If the wind shear is strong, okay, which is, remember, which is a change in speed or direction with height. If it's strong, then those two things are separated. The updraft is in one location, the downdraft is somewhere else. As those are separated, that can make the thunderstorm stronger and longer lived. Because as those stay separated, they don't interact with each other, and then that storm can continue. So if you think about the Taylorville tornado from December 1st of 2018, that one storm traveled from Litchfield all the way up to east of Bloomington. One storm. It kept cycling over and over again, and that's because the updraft was in the back and the downdraft was separated and was up further to the northeast from that. They were close together, but they were far enough apart that the storm just continued to go. All right? So that's how storms last longer, is when those two are separated. So strong wind shear, stronger storms, more severe storms. Now, strong wind shear also does something else. It creates what we call a horizontal rotation or a horizontal roll. So what happens is that you see that on this picture, air is flowing from here into the screen, and then you've got air above flowing from left to right, okay? That's going to create a roll, as you see here. It's invisible. You usually don't see this, okay? It's not something that's coming out from the storm. This is something invisible that you can't see. It's something we know is occurring because we know the wind is changing in direction with height and also with speed. When an updraft begins over this, it's going to start to tilt and pull that roll upwards. It doesn't disrupt it because you're still going to have this rolling air, circular, okay? On a horizontal axis, you're going to get this rotation. And the updraft is going to pull that up. And as it pulls it up, it's continuing to rotate. So now you have what we call a rotating updraft. So that's creating like this vertical rotation, right? In this kind of a fashion. And if you're looking straight up through it, it's going to be rotating clockwise. But if you look straight down, it's called counterclockwise. We have different term for it, but that's the way it looks. So what happens is that the updraft pulls that rotation up. It doesn't disorganize it. And now you have an updraft that's rotating on a vertical axis in this fashion. Okay? Makes sense? Everybody still with me? You still with me? You good? Yeah. You good? The little girl down there. That's good. All right. Okay. That's good. That's good. All right. So that's why shear is important. All right. That's why shear is important. So we have strong wind shear. We're going to have more severe storms. That's where you're going to get your larger hail, your tornadoes, maybe your higher wind. All right. Let's move on from that. All right. So as a spotter, how am I going to see this? Right? How am I going to see this going on inside a thunderstorm? Well, there's clues that we can look at. All right. And this picture shows you all of that. I'm going to start at the top. So at the top is the overshooting top of the thunderstorm. If you're far enough away, say 30, 50 miles, you might be able to see this. The reason that's important to see is because that's where the updraft is located at. That's where it's punched through what we might call a ceiling, right? The air is continuing to rise. Let's say it's traveling upwards of 120 miles an hour. That's pretty fast for an updraft. All right, you're going to get some pretty severe weather out of 120 mile an hour updraft. So as it gets to a certain level, it just kind of pokes through the top. Can't go any further. It's poking through the top. The rest of it that doesn't go out the top kind of spreads out. That's called the anvil that you see up there. All right, that's the anvil where the air is spreading out as it's rising upward. So inside that storm is your rotating updraft. Then on the forward side, you see a forward flank downdraft. That's your downdraft. That's your initial downdraft where the rain is coming and some of the wind and so forth. And typically the storm is flowing in that direction. All right, it's flowing, I'll just use this as an example, it's flowing to the northeast. That's where, that's the direction that the downdraft is going to be at, the forward flank downdraft. On the back side, there's also another downdraft, because what happens is that the updraft becomes and acts like it's a solid cylinder almost. All right, so it's rotating, and then it affects the wind at those, say, 10 to 12,000 feet. So what happens to the air that comes in from the back? Some of it goes around, right? But some of it actually goes. So we get what we call a rear flank downdraft. So the stronger storms, the supercells that produce the strong tornadoes have actually two downdrafts, but they have also the updraft. And on the back side of those storms, you can see all these features. Underneath the storm is where you see your rain, your hail, all right? Underneath the forward flank downdraft, you see your wall cloud, which is rotating. We'll talk about that more. You also see what we call a tail cloud, and then your tornado would form underneath that wall cloud, or on that wall cloud area. Okay, so visually you can actually see this if you're far enough away. If you're really close in, like 5 to 10 miles, it's going to be hard to see the stuff above, but you're definitely going to be able to see the stuff below at the base of the storm. So that's a little drawing, but this is an actual thunderstorm. Main updraft is in the middle of that, underneath the overshooting top, but above the wall cloud. You see with the forward flank draft where the rain and the wind is at, and then on the back is what we call a flanking line or a rear flanking line. That's kind of where a lot of the moisture and instability is being pulled into the storm. All right, so that, and as long as you see something like that, that storm's probably going to continue. So that's how thunderstorms develop and go on. And let's talk about specific things underneath those storms that are important that we need to know and that your communities need to know as well. We're going to talk about supercells, which are the big daddies of them all, and we'll talk about tornadoes, and we'll talk about other things that spin too. Some things spin that are tornadoes, and some things spin that are not. All right, so this is a little bit different than the tornadoes that we like to talk about. This is something more. So let's first talk about supercells. Two types of supercells. There are classic supercells, which are the ones that produce the long-lived tornadoes, the very large hail, the heavy rain, also the damaging winds. All right, there's a classic supercell that you see there on the left, off in the distance, right? Typically easier to see. They're very large. The tornadoes, you can see them because they're on the back side. right? They're a little bit easier to see. And then the one on the right is what we call an HP supercell or a high precipitation supercell. This one has a lot more rain, okay? It's a little bit differently, but the key factor is that it still has a rotating updraft. All right, it still has a rotating updraft. We get a lot of these in the Mississippi River Valley area, including us, Midwest. We get a lot of and a lot of them occur at night as well. You get heavy rain out of these. And a lot of times the tornadoes are not well seen because they're rain wrapped. And I'll explain that when we look at some radar images on how it's harder to see the tornado because of the rain wrapping around it. They're very dangerous to spot because you can't see the tornado wrapped around the rain. And I will add this, is that what we know scientifically is that 85% of all supercells, okay, talking about a rotating updraft, 85% of all supercells produce severe weather. 85%. When we see a supercell with a rotating updraft, we know we're going to get something. Hail, wind, maybe tornadoes. We know we're going to get severe weather, all right? But not all thunderstorms produce tornadoes. Not all thunderstorms produce hail. But with a supercell, we're almost guaranteed you're going to get some sort of severe weather out of that. So that's why we're kind of focusing on supercells. As I mentioned, both of these, the classic and the HP, have rotating updrafts. Sometimes when you're closer in, you can see these spiral bands giving you an indication that it's probably a large rotation that's occurring up there. And a lot of times if you're stationary, which we recommend, you're going to be able to see that rotation. You're actually going to see that storm rotating. Now, if you go out into the plains where there's no trees, all right, where you can see for miles, you can see these storms as they're developing, and you actually see them rotating and rotating upwards. They look kind of like an old barber pole. If you've seen those before, that's what they look like. You actually can physically watch it, and you're like, wow, it's pretty amazing. But here, for us to see those, because we have so much moisture and humidity in the air, at times it's real murky, and it's more difficult to see. When we're in the office, what we see on radar is that rotation, right? And if 85% of all supercells are going to produce severe weather, that's what we want to see. We want to see the rotation going on inside the storm, because that tells us something else is going on, something else is happening. And then it's like we need stars to tell us what's going on underneath the storm. Is there a wall cloud? Is there a funnel? Is it producing large hail? Is there damaging winds? That kind of stuff. So we always need to know that. So watch this image or this video as this storm is moving toward the Champaign area from a few years ago. You can kind of see, you see how it's kind of curved, right? That curvature there. You know that there's rotation going on inside this storm. Now this is underneath it, rain-free base. Don't think it did not produce any severe weather, but the winds are a little strong. Wasn't too bad. But it's a good image or good video of that occurring, the rotating updraft, the rotating storm. So you get a good idea of that. And so, like I mentioned, you want to be a stationary spotter because you're going to better off be able to see that actually occurring if you're actually going around chasing or whatever. All right, so now we talked about all the features above, right? The overshooting top, the anvil, the updraft region. Now let's talk about what goes on underneath the storm. The first thing we want to talk about is the wall cloud. The wall cloud is a persistent lowering near or in the updraft region, which may be rotating. We really need it to be rotating in order for it to produce a tornado or funnel cloud, but you really need it. Sometimes the wall clouds are moving really super slow, and you can't see it very well. But a wall cloud is something that we look for in that free base. That's in the updraft region. That rain-free base is where you're going to see that wall cloud. And there's a feature called a tail cloud that sometimes occurs. This tail cloud actually points toward or it points toward the downdraft area, okay? It points toward the downdraft. Won't go into what causes it, but just remember that. If you see something pointing away from the rain, that's going to be not a wall cloud, all right? Sometimes you get these tail clouds on the leading edge of a squall line, okay, or the line of storms, you get these leading edges, and sometimes you see something pointing down on those. That's not, there's no wall cloud there. That's the tail cloud. That's part of the gust front that's actually pointing away from the storm. If you see a tail cloud connected to a wall cloud, that tail cloud is going to point toward the rain itself. So the wall cloud should be cloud and air also rising upward as well. So you know you're in the right region to see something develop underneath that storm. And if you're out, if you're driving, if you're on vacation and you see that, then you need to be paying close attention. You might want to have to pull over and, stay out of the way as it's developing. So that's a wall cloud. Now they look different. They all look different. None of them look the same. Sometimes you don't even see much of a wall cloud. Sometimes you see a lot of, definite wall cloud. Here's one here from 22. All right, there's a wall cloud there. You see the wall cloud is in the rain-free base, and then you see the rain off to the left of that, which is where your downdraft area is at. Testing, 1, 2, 3. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3. Testing, 1, 2. Okay, that's good. All right, so here's an image of a wall cloud, and you can, like I said, you can see the updraft region is the rain-free base, and the downdraft is where the rain is. That wall cloud's in the right place. It's probably rotating, so this is a supercell. It may or may not produce a tornado. You just have to keep watching it. Here's another wall cloud. See, it looks a little bit different. This is taken from a different vantage point. The rain is to the left. That is true, but that's because the person is looking from a different side. All right, he's probably looking more from the north side. And you see, this might be actually an HP as well. I don't remember that day. But this could be an HP, and sometimes with an HP, the more rain is on the back side. All right, but we'll get into that a little bit later. All right, and here's another one. This is from December 1st of 2018, over by the Illinois River Valley. And this one you can see, good picture from a distance. So it really exhibits really well the updraft area where the storm is developing right here. That's the rain-free base. The rain's off to the north and to the northeast there. There's your wall cloud. This storm actually had a history of producing tornadoes that day. Produced 6, something like that. I forget how many tornadoes this one produced. This is December 1st, same day as the Taylorville tornado, but not the same storm. It was a different storm. That one was at night. It was more in the night, and you couldn't see a lot of it. So after you get the wall cloud, typically you get a funnel cloud. The funnel cloud is going to be funnel-shaped, so to speak, and it's associated with the rotation somewhere around the wall cloud area. It's also in the rain-free base, usually with a classic supercell. And it's vertical, and it extends down to the ground, but it's not touching the ground, okay? It's not touching the ground yet. So if you're the spotter and you see this, you want to look below the funnel cloud to see if it's going to start touching the ground. And sometimes you can see some things that'll give you an idea that it is actually touching the ground. But in this situation, this one eventually touched down, but it was pretty weak when it did. It didn't actually do any damage. And then it develops into the tornado. At least that's typically what the process is. You go from a wall cloud, funnel cloud, and then you get a tornado. Sometimes that can take 30 seconds. Sometimes that takes 5 minutes, 10 minutes. It just depends where and how strong the storm is and how strong the wind shear is. But you get the tornado, and by definition, a tornado is a rapidly rotating column of air that's connected to the base of the cloud and contact with the ground, right? So that's what a tornado is. Now, it doesn't say, the word visible is not in this definition, because if you've been around Illinois for a long time and seen tornadoes before, you know sometimes you don't see a condensation funnel all the way to the ground, even though you're getting damage. The previous slide that showed the funnel near Illiopolis, that was one of those days. It's like, well, there's a funnel cloud, it hit the ground, but it didn't connect. There was no complete connection, but it still was doing damage. So, well, that one didn't, but others did. So that's what a tornado is: violently rotating column of air that's connected to the base of the cloud, and it's connected to the ground. And on a classic supercell, that's going to be on the back end of the storm. Okay, classic supercell back end, where the updraft region is. Classic supercells, high degree of shear and instability. The rotation will extend way up into the top of the cloud, which is only visible on radar to us. You're not going to be able to see that physically unless you see the effects of it, and the storm is rotating. Spotters will see the wall cloud, eventually the funnel, maybe develop into a tornado, and they also can produce large hail, damaging winds, and some flash flooding. So we have to be careful of that as well while we're watching these storms. Typically, they move along quick enough that you don't get a lot of flash flooding. You just get a lot of rain in a short amount of time. It might be really brief. But if they're slower, then we can get a lot of rain out of these. Now, just looking at a drawing of radar, this is kind of what a supercell looks like. All right, so you can kind of see some of the features here. You got the forward flank downdraft, which is out ahead of the storm. It's in the direction the storm is moving. Okay, this storm would be moving to your upper right in here. Okay, the rear flank downdraft is on the back side. That air descends down and it actually curls around and gets up underneath the updraft region. That updraft region is going to be right here where that triangle is as well. I should work over here so other people can see my pointer. But there's where your updraft region is, where that triangle is. That's where the tornado is going to develop as well. That's where your wall cloud's going to be. That's where your tornado is going to develop, funnel, all that kind of stuff. Up in this area here, close to the updraft, all right? Between the updraft and the forward flank downdraft, that's where you get your hail. Damaging winds can come out of the front as well, but also on the downdraft region, you can get a lot of heavy, the rear flank downdraft, you can get a lot of heavy, high winds as well. Very strong winds, sometimes up to 100 miles an hour. So here's an actual radar image from December 1st of 2018. This over by Havana, and we had one of our TV meteorologists out there chasing it that day, or following it, Chris Yates from Peoria. And this is what the radar looked like. The spotter was here down in Bath, and that's what they were seeing off to the northwest, off in the distance. All right, that's snow. We had snow before that, but then yet December 1st, 2018, if y'all remember that, it was pretty warm. Like in the 60s, dew points were pretty high too. It was like, it's a nice day, gonna go outside and do some stuff. No, gonna go hide and get protection, right? But here, this rotation, this where the circle is, that's what we would call the debris ball. That's where the rotation was, southwest of Havana. So there's actually debris inside that little rotation there, that little ball there, right there. Because this is what it looked like on radar when we were looking at the wind. Now, we can see the reflectivity. We can see what the storm looks like, but what we want to see is inside. We want to see the wind, all right? And this is what the image looked like that day with this particular storm. Now, the red is air flowing away from the radar. The radar in this picture is actually off to the right of your screen where Lincoln is, okay? So if you're familiar geographically, you know that Lincoln's off here to the right, east of Havana, east of Bath in Logan County. So the red colors are winds flowing away from the radar, and the green colors are winds flowing toward the radar. All right, winds flowing toward the radar. So the brighter the colors, the stronger the wind. The closer together they are, as you see in this picture, then the more likely you're seeing rotation. All right? So with this particular image, you got really high velocity flowing away and high velocity flowing toward. We're getting rotation right here. Because they're so close together. Now you can see them further apart, but that doesn't mean there's rotation. All right? They've got to be close together to give you that rotation. Briefly, the way the radar works is it samples the air flowing away, flowing around the radar and flowing toward the radar. Okay, and so how many of you have seen any policemen here today? Any police? Okay. No? Okay, good. I'm safe. All right. How many of you have seen policemen in the medians on the interstate? Right? Yeah. And the reason that's where they're sitting is because that's the most accurate reading they can get, is directly 180 degrees of you. So if you're going away or toward them, then they're going to get an accurate measurement. So our radar works with the same principles as if he was trying to gun you and you're going perpendicular to him from side to side, it's going to come back with a 0. So in our situation, it's the same way. If the wind is flowing perpendicular to the beam, it's going to come back with a 0. The wind speed is 0. That's because the frequency doesn't change. All right, because we use the Doppler, it's called Doppler shift. We use that frequency. You can hear it when a train goes by. You hear that in your ear. The sound changes. The sound actually changes as the train is moving. So there's a difference in the pitch. That's the same thing. It's in our ears, but that's what the radar guns that the cops use. That's the same thing. So as the winds are directly toward or directly away, you get a more accurate reading. And that's when they're closer together. That means we're getting the rotation because you're not seeing the side-to-side motion. So there's definitely rotation in this particular storm. That's what we want to see. And then that's when we need spotters to say, hey, this is what I see underneath that. Okay, warning's going. Or a warning's already out, hopefully. And then there was. In this situation, a warning was already out because this storm actually had a history of producing tornadoes. So that's the way the Doppler kind of works for us. And that's why we need to see what's going on inside the storm. So anything that messes with that, we don't like, okay? We don't like it when it messes up with the rotations. Like, we need to see that. That's important. So the classic supercell life cycle is one like this. You get the wall cloud, you get the funnel cloud, you get the tornado. Then we get something called this bright area. It's part of the rear flank downdraft. That's the visualization of that rear flank downdraft, is this clear slot, this clear area. That's where the air is actually descending and kind of clearing out some of the clouds. And as it comes down, some of that air gets rotated into underneath the updraft region. And we know that the rear flank downdraft is very important. All right, it's very important because that air needs to get up underneath that updraft, and then that's what really starts to generate the tornado. You can have a funnel cloud, but if that air is not getting down underneath it, or if it's too less buoyant, so to speak, then that air is not going to start to rotate and lift up in it, and you're not going to get that tornado developed. And we've seen that. We'll see supercells, and they don't produce tornadoes. You know, they'll just produce funnel clouds and give us a headache. You know, do it or don't. So, but this the way it carves it out like this, some people call that a horseshoe shape, kind of the appearance it has. But just remember, if you see this on the backside, what you're seeing next to the wall cloud area, what you're seeing is that rear flank downdraft coming down and getting up underneath the updraft region. And then that's the area you want to look. And in this particular picture, there's actually a tornado there that's developed, but that's the area you want to look, where it kind of coincides together. So once you see that funnel, once you see that rotation, you want to start looking at the base of the ground. This was a couple years ago, almost 2 years ago, near Assumption, Illinois, and you see here that you have a funnel cloud. And he's pretty close to the storm, so he's not seeing all the other features, but he's underneath it. And you see the funnel cloud, but you don't see anything in between, but you do see debris being kicked up here. All right, so a tornado is not necessarily a solid object. It's a violently rotating column of air, of wind. And it's you don't always see it complete like that, or you don't always see it complete. And here's a good example of that. that did do a little bit of damage out near Assumption, north or south of there, I forget where. But this is actually a tornado. It's not a funnel cloud touching the ground. It's called a tornado. And this is what we look for. This is what we hope the spotters are going to see for us. I got a funnel cloud and I start to see debris. Then there's a tornado, all right? Usually, this is what most people think they look like, right? Big stovepipe, that kind of thing. This is when the mature stage of the thunderstorm, a mature stage of a tornado. And this is usually when they're the most dangerous because they're really violent and rotating and they're doing a lot of damage. So that's usually what they look like. And that's what most people think of, or they think of these big wide wedges, as we call them, that are moving across the ground. Here's another one. You can see we call that a wedge. You got a big, large tornado. That's what people expect to see. Recently, over the last few years, that's not what we see anymore. We're seeing these little wimpy things that touch down and don't do any damage, or destroy an outbuilding and move on. But this is kind of what one would expect a tornado to look like. Sometimes the debris gets in there. It messes up with the condensation funnel. You get dirt and stuff like that. So sometimes you're like, oh, it's not there anymore, but I see a bunch of debris, dirt and stuff. Well, no, there's still rotation on the ground. It's still doing damage. It's there. You can tell. This one is especially because there's a lot of debris there that's being kicked up on the ground. There is a dissipating stage to these. They're called a rope stage. And as you can see with these two pictures, they're pretty skinny. Sometimes they start falling apart, and they can still be damaging. They can still do damage, right? But they are falling apart. It's dissipating at this point. However, sometimes more tornadoes develop, or another one develops a little bit later. It's called cyclic supercells, as we call them. The Taylorville tornado, that was one tornado out of 9. Taylorville tornado was 1 out of 9 tornadoes out of the same storm. And that's because it started to redevelop another tornado a little bit further to the northeast. And that can happen, and we're going to talk about that here. But if you see this dissipating, you need to look to your left. You need to look elsewhere and make sure that there's not another one developing. All right, another wall cloud, another area that might produce a tornado, and that happens sometimes. So you have to be careful if you're out spotting. That's why you want to be positioned in the right place. So here's a good picture of that. You see the dissipating tornado there, right? And then you see the next one that's developing just off to the east or northeast there in that picture. So that's classic supercell, or classic supercell with cyclic tornadoes is the term we use. And we've had several of those throughout the years. Here's the Taylorville tornado. This is what the radar looked like. The image on the left is the reflectivity, all the rain and stuff and hail. I don't think it actually produced that much hail, actually. And then the image on the right is where you see your rotation. You see the green, the high green is the wind flowing toward the radar. And then the red is the wind flowing away from the radar, okay? That's the way the wind looks to the storm itself, all right? It factors out the storm motion throughout the whole screen, the whole radar screen, and it says, okay, I'm going to set the storm to 0, so to speak, so that I see what the air looks like in reference to the storm, not what the air looks like in reference to the office, but what it looks like in reference to the storm. So if the storm motion is different than whatever all the other storms are, you're going to see something different when you do something like the way we have it here. So it's storm relative motion is what we call it. But that, again, you can see the rotation there. But if you look to the northeast of that, that's a later image, sorry. Oh, it didn't show that. Okay. I was going to say there's another image just after this where you can see additional. Oh, wait a minute. No, that's right. This is Taylorville down here. I've lost my geography here. You can see there's another high inbound right here. That's the secondary wall cloud, or that's the next place that the tornado is going to be developing away from Taylorville. So the tornado went up into Taylorville and moved north, and then we had development begin just to the northeast of Taylorville, and actually produced a tornado
just outside of Stonington. All right, same storm, but it continued and produced more tornadoes. So let's talk about the HP supercells. High precipitation. They're supercells, so they have a rotating updraft, but the location of their downdraft is a little bit different. Spotters, this is typically what you can see. You'll see that horseshoe look. The downdraft, the heavier downdraft is actually on the back side of the rotation, not the front side. There will be a downdraft on the front side, but the back side is where most of it's going to be located at, and that's where all the rain's going to be located at. It also has a wall cloud, sometimes harder to see because it's at night. There's a tornado there, actually. I don't know if you could see that. Light was kind of fuzzy there, but you can see there's actually a tornado with that storm inside that rain. So that's difficult to see. That's why HPs are harder to spot, because it's the downdraft, the rain gets wrapped around the tornado itself. Here's another example of that. Safest place to be for these is somewhere south of the storm, right? As the storm is moving, from your left to your right, you want to be south of the storm. The low-level rotation is obscured by rain, and so is the tornado. And sometimes you do start to see what you would call, or what we would call, as a wall cloud. Kind of in a connection there in that area. That's the area where you want to keep an eye on it, because that's the location where you might start to see some rotation or a funnel or even a tornado touch down out of that. Here's an example of one on radar. Got a kidney bean look to it. Most HP supercells, that's what we call the reflectivity. The way the radar looks to us is kind of like a kidney bean. The inflow and the updraft on these is actually going to be near the front in this area here. All right? That's where the updraft region is going to be, is in this area right here. Call that a notch. That's kind of a notch. Looks kind of like a hook. If you look at the little red area there, kind of a hook, but we call that an inflow notch. That's where the air is flowing into the storm. It's also rotating as well. And then you can see that on the storm relative. Again, the red is flowing away from the radar, and the green is flowing toward the radar. And in this situation, the radar is somewhere off to the northeast there. So you're getting rotation. You're getting rotation in the storm. The rotation in an HP supercell typically is a little bit weaker than a classic supercell, but you are still getting rotation on that. And that's what we want to see. And then it's like, okay, spotters, what do you see underneath? A lot of rain. That's it. It's like, okay, then be careful, because there might be a tornado in there that you can't see. Now, there are exceptions to the HP supercells, meaning that sometimes the rotation is in that inflow notch. Sometimes the rotation is somewhere else. In this situation, this was an HP supercell. This was November 17th of 2013. How many of you remember this day? Anybody? What happened that day? Washington got hit by an EF4 tornado. Yes, that was on this day. But this is not Washington. This is Gifford. This is northeast of Champaign. And this was not the Washington tornado. That storm was a classic supercell. This was an HP. So we had both types on the same day. It was a Sunday morning, Sunday early afternoon, and we were getting an HP. And this is the way that storm looked like as it was moving toward Gifford. And you're like, well, where exactly is that inflow notch? What kind of heat? Is it here? Is it here? Where is that? So it's kind of hard to see. So there's nothing really clear as to let you know where their actual rotation is. But this image does tell you where the rotation is. Well, no, I'm sorry, not this one. That image shows you what the spotter was seeing. Jesse's one of our great photographers, took some good pictures that day. And that's what she was seeing off in the distance. Notice it's kind of fuzzy. There's a lot of rain there associated with it. So she was located here where that star is. And I'm not sure which way she's looking, but maybe this next image will help. Oh, she was looking north. I would have thought the rotation would have been to northeast of her, but she's actually looking north, and that's where the rotation actually was. So she was looking north. So all that rain that you see here is going to get pulled around to the backside of that tornado. So watch the images on the left. You'll see a sequence of pictures of what it looked like as she took pictures. There you see the rain beginning to move down into near the updraft area or near the rotation. Now it's harder to see the tornado. And now you can't, if the lights were dimmer, you could see the tornado, but now you can't even see the tornado. It's all rain wrapped. Very dangerous at this point. When the storm got into Gifford, yes, it was an EF3 tornado. When the storm got into Gifford, that's all people saw was that. Just a bunch of rain. They didn't see the storm, though there was a warning out for it because it had already looked like it was going to produce a tornado. So HP supercells are very difficult because of that region there. Now we get other tornadoes that are weaker. These are common in our area. We get tornadoes with what we call a line of storms or a squall line. All right, so remember, tornadoes develop underneath the updraft region, right? The updraft region. So where's the updraft region on a squall line? It's usually on the leading edge, which means, yes, you can get tornadoes in those areas. So rotation may be visible on radar, but not always. Sometimes we might see the rotation. It'll be really shallow, so the further away these are, the harder it is for us to see the rotation in the storm. They're very difficult for spotters to see due to lots of rain nearby. They're not really HPs, okay? They're not classic supercells either, but there is rotation in the storm. It does produce these tornadoes. They can produce EF2 damage or less, usually not very high because they're usually short-lived, very, very short-lived. And but they do produce tornadoes at times. On radar, this is what they look like. You can kind of see, we look for these inflow notches on the leading edge. Okay, you can kind of see that there's some rotation there where that triangle is. So there's certain places where you can see these tornadoes, like the inflow notch area, or where there's a kink in the line or a broken part in the line, or the tail end. That's kind of where we can get tornadoes on these type of storms. Then we also get what we call land spouts. Now, what I'm describing here, the tornadoes with the line or land spouts, these are tornadoes, all right? Tornado, remember what the definition is: violently rotating column of air in connection to the base of the cloud and connection to the ground. So land spouts are considered tornadoes. We have other things that spin that are not tornadoes, and I'll get to that. But with land spouts, they're translucent or transparent in a way. They rotate. They're usually out in the open someplace in the field. All right. They can move. They can move quite slow. Right. Don't know what they would do if they actually hit property or an outbuilding or something. I'm guessing that they would do some damage. And sometimes they occur in multiples, like more than one. We haven't had any of these, I don't think, in a while. I don't think so. When the rain develops, they typically start to dissipate because the rain is the downdraft area. That downdraft area gets caught up near the updraft and it kind of cuts it off. We typically will see them like late April through June time frame. I think we've seen them later than that at times, as long as the conditions are right. And here's a video of one. This was a while ago near El Paso. But if you notice, you watch this, out over a field, freshly planted, I believe, or something like that. And notice it starts to lift off the ground. And it just kept lifting and just, it wasn't touching the ground, but it was there. It was really weird. Very photogenic, so to speak, because they move quite slow. Now we get some other rotations that we don't call tornadoes, all right? One of those is called gustnadoes. Sometimes with outflow boundaries from a storm, the air comes out and it'll produce what we call a gustnado. And there's a video coming up that shows you what they look like at times. But they develop on that gust front. We don't call it a tornado because it's not in connection to the base of the cloud. There's no wall cloud. There's no rotation that we can see, all right? But it's on the outflow of the storm. So there's an image of kind of what they look like. You do see maybe a gust front, shelf cloud as we call it, and then sometimes you'll see this little eddy that develops. Okay, it's just a little eddy that hits the ground and starts to spin a little bit. Could create some minor damage, but it's more wind damage than it is, okay, than a tornado. It's not a tornado. We do get these several times a year. It's a struggle for emergency managers at times because they'll get calls and they're like, I'm getting tornadoes over here. And it's like, probably not, you know, because maybe it's a day that's you're not expecting tornadoes. A lot of times that's when they occur. It's dry out, maybe the fields have been freshly planted, a lot of dirt is loose, and you'll start to see these, and thunderstorms will produce these on the outflow boundaries on the gust front. We also get what we call cold air funnels, or is what some of us call just non-thunderstorm funnels. We will get those. Sometimes the atmosphere is not conducive for cold air funnels, which is a little different. They develop in the mid-levels, and then the funnels just kind of hang there, and they can last for an hour, but they're not dangerous because rarely do they touch the ground. I think in my 30 years, I think there's maybe been one or two that have touched the ground, a cold air funnel. They're usually pretty high base. They don't reach all the way to the ground. They're very photogenic. If you want to take a picture, they'll smile for you. But if they reach the ground, then they probably could do a little bit of damage. We also get non-thunderstorm funnels, they develop differently. Here's a good video of some cold air funnels that occurred. There's actually multiple on this video, side by side. Birds are singing. You know, they're not afraid. So yeah, they're just, you know, fun to look at. They scare people, which I'm not surprised, but because part of being a spotter is being prepared, and we'll talk about this in the second half. Part of being a spotter is being prepared, right? So if you see these, but you know that we're not expecting supercells that day, it's like, okay, I don't need to worry about this as much because it's not going to produce a tornado like something else would because I'm not expecting supercells. Let's talk a little bit about damaging wind and hail. Thunderstorms can produce both. I mentioned that downdrafts, we can get these downbursts, as we call them, or microbursts. Rain-cooled air rapidly descends down to the ground. It's an intense downdraft. You get really high winds. You can get winds over 60, 70, maybe 80 miles an hour. They can produce quite a bit of damage as well. Most of the damage is pushed off into one direction and kind of fanned out as well. Okay? They can last several minutes, and sometimes the wind direction will change because you're actually getting a storm that's producing the downdraft, but it's also moving at the same time. So sometimes you'll get one direction one way, and then the wind switches and goes the other way. So that you have to be careful with. That's kind of what they look like in this video here. Here's another image of a downdraft. Rain just descends very quickly. There you go. Damage can be as high, sometimes over 100 miles an hour, which is the same as an EF2 tornado. So as when I talk about the safety portion of it, I like to bring this up because it's like, well, then what kind of protection, what should I do to protect myself from a downburst of over 100 miles an hour? Same thing you would for an EF2. Same thing you would for a tornado. You find shelter, right? Because they can do the same kind of damage. Another downburst here. Notice this one circled that little area that's kind of out there. Looks like a little curl. We call that a rain foot. Because that air descending really rapidly gets down to the ground, and then it's going to push out. But it's got to go somewhere because it's not going to go through the ground. So it kind of rotates back up. Sometimes creates a little roll there. And that's usually where your stronger winds are located at, is in that area. And as I mentioned, the wind can change direction because the storm is also moving. And then you get the wind will flip on you as that storm moves by. Squall lines can produce these damaging winds. They produce shelf clouds out on the leading edge. Typically what you have is that the updraft area is out ahead of the storm and the downdraft is up in the middle on the backside of the storm. Okay, the downdraft is where you get your high wind, your driving rain, and then on the updraft region is where you kind of want to look for that rotation. Maybe you might have some rotation there. Not always, not all squall lines produce rotation, but it's something where you want to look out for as a spotter. Severe shelf clouds, you can kind of tell by looking at the shelf cloud if it's going to be severe or not, meaning if it's going to produce winds over 60 miles an hour, right? So the leading edge, if it's well-defined, if it's pretty deep, if it's really kind of nice smooth look to it, then you're going to get some higher winds with that. Some of the times the winds are not that strong. Sometimes there's low-hanging clouds, as you see with this one, little fingers or whatever you want to call them. Some people confuse those and think that that's rotation, that it's a funnel cloud, but generally it's not. So you just kind of got to watch them and be careful while you're doing that. But typically it would be you're going to get some wind out of it, all right? either minor wind or some strong damaging wind. So you really need to be careful of that. Then you've also got this area. That's kind of where you would look to see if there's any rotation, is that area that's circled right there. Here's a radar image of a squall line as it's moving through. Notice that it's kind of pushing out ahead of it in this area here. The highest wind is going to usually be where that push is, right? It's kind of like it got a bow to it, all right? And where that push is located at, that's where you're going to get your higher winds and your heavy rain as well. Sometimes the highest wind can surge several miles ahead, like you see here. There's a little boundary. Again, I mentioned that we like to see the outflow boundaries on our radar, and this is the case where we can see the outflow boundary on this one. So it could be several miles ahead. If it gets too far out ahead of it, it's cutting off that updraft, and that storm's probably going to die or dissipate. Here's another radar loop of a squall line moving across our whole area. The video on the right will play, and that actually is, that's the squall line actually moving over the spotter. It's located about where that arrow is. How many of you have experienced a squall line like this, where you can see it come in, it's like, oh, all this wind and rain? Yeah, they're pretty common around here. Usually it cools off too, right? When that downdraft air comes in, it cools off a little bit. And then for hail, real briefly, the way hail develops is that the raindrops get pulled up above the freezing level, and then they freeze. And then sometimes they circulate back down, which means they gather more rain, and they circle around for a couple of times, and then get lofted up. And then they usually get lofted up by the updraft. And the larger hail that you see on the ground, that means it's been lifted up for a long time, right? Because what happens is that gravity takes over and then it falls out. So if you've got a really strong updraft, you have the potential for getting very large hail. If you see golf ball or larger hail, like softball size, you know you have a rotating updraft, you know you have a supercell, all right? The supercells will produce the largest hail. And we've had softball size hail before. I've not experienced that, which I'm glad, because I think that would hurt a little bit. There's some large hail there just recently. So the biggest hail is, again, associated with the strongest updrafts. Golf ball or larger is usually when you got a supercell, because the rotating updraft can hold larger hail aloft. Sometimes storms will actually throw the hail out the top, and then the hail will land in areas where it's not even raining. We've experienced that. Hey, I got hail. I'm like, you're not in the storm. No, but I got hail. So it'll throw it out the top. Very unusual, but it's very interesting. And hail can do quite a bit of damage. This is why we recommend like people be stationary when they're chasing, and we'll talk about this in a second, and have a good safe shot to go to if the storm's coming your way. Okay, I don't know about my insurance company or your insurance company, but if my car looked like that from hail, I better have a good reason for why I was out there. And also, it does damage sighting. Wind-driven hail is the worst. Wind-driven hail is the worst. And sometimes, as a spotter, you can see the hail off in the distance. A white streak like this underneath a storm is a good indication that you have a hail shaft. So there's hail occurring in that area. That's the location that you don't want to go to, is that area. But if you do see that, and sometimes people do, they're harder to see usually because there's usually rain. But if they do see it, this is what it would look like. Now on radar, we do have some features that we can see to let us know that hail is actually inside the storm. One of those is where we get this reflectivity on the backside of the storm itself. So the radar is over here to your right, bottom right. All right, and so we get this shadow, so to speak, on the backside. We're like, what is that? Well, that's the radar beam actually going down to the ground, coming back up, hitting the hail again, and coming back into the radar. And it's a reflection of that, and the radar doesn't know where to put it, so it puts it on the back end of the storm. But what is actually going on here is that there's large hail inside this particular storm, right here where some of this purple and pink is. And then we also have an image that we can see an estimated hail size. And this particular storm estimated 2.25 to 2.5 inch hail, and that's what actually fell out of this storm, was up to 2.5 inch hail. So that's a pretty good sized storm. So at this point, we're going to take an intermission, 10, 15 minutes. What time is it? 9:48. Okay, we got lots of time. We're going to have a quiz after we come back. I'm going to have stuff up here where it's going to help you. How many people have used Kahoot before? Kahoot, are you familiar with Kahoot? I know teachers use it. Okay. You can download it onto your phone, and it doesn't cost anything, and you don't have to log in. I do know that. So we're going to have a quiz, and it's going to be through Kahoot, and we'll have the link. The link information will be up here on the screen when you come back. So let's be back here a little bit after 10 o'clock. Okay? Thank you. And if anybody has any questions, I'll be up here setting that up so you can come up. wants to play. Remember, you're going to be graded. This is the quiz, and we'll pass out the grades at the end of class. Just kidding. We don't grade these. But you do get points as you play. The faster you answer right, then the higher the points are on your score. And I checked. I've got it on my phone. It's working just fine. They've upgraded it since the last time we used this. All right, everybody ready to play? You ready to go? I see one thumb up. Anybody else still waiting? We got 19 people. That's about half. If you can, if you want, yeah. Oh yeah, that's fine. Because it's always up there as far as I know. So I don't think the quiz goes away. And we've got quiz from several years ago, so you can go back and play a different one. Okay, here we go. Everybody's ready, right? Yes, yes, yes. Okay, I'll take that as a yes. Is winter over? Question number 1. Okay, everybody said no. Well, yes would have been a good answer too. So just to get used to the quiz, okay? There was no right answer for this one because we don't know. But I would agree with you. No is the right answer. Okay, next question. This is real. Everybody got high scores. Radio guy got 934. Okay, next question. Here we go. Is this a tornado? Ding. Oh, yes. Very good. They got that. Good job. That was a tornado, yes. You can see the clear slot right here, right? Yep, you can see my cursor. You can see the clear slot, big wall cloud. There's the tornado. Very good. All right. Really? Where? Where? I don't see. Okay. Okay, this is true or false. A tornado is a visible rotating column of air. We covered this in the topic earlier. I teach to the quiz. Okay. Need to review this? Sorry. No, it is not a visible. It's a rotating column of air. Yes. Visible? No. Doesn't have to be visible. Does not have to be visible. I'm liking that guy on top right now. Okay, what is this? Multiple choice. Okay, if you said tornado, that was correct. Or if you said landspout, that was correct as well. So do we need to review one? No? Okay. Well, still in the lead. He's got a big lead right there, 400 points. Next question. What is occurring here? It does not have to do with the wind towers. This is a hard one. Ooh. Yes, it is Berga. The first few ones were easy. This is a hard one. It's okay. Don't feel bad. Oh, what? Ron DeSantis, you got it wrong. Now, granted, we haven't covered this yet, but okay. Oh, good job. Yes, that was a scud cloud. I will review this one. Did you get the rain on the left, on the right? Right? You'd like, well, it's in the rain-free base. It's there, like to the left of the rain. Yeah, no, it wasn't rotating, so it's hard to see that in an actual picture. But okay, two more. Quiz. What is the white feature? What is this white feature? We covered this in the first half too. Good job. Okay, good job. Yes, and if you did say rain shaft, that's kind of right because there is some rain there too. All right, so I'll give you half credit for that. All right, last question. Let's see if this will play. Here we go. That was it? Wait. What? Why did it take so long to play? Sorry, I didn't realize I was going to do that. Internet connection, connecting to YouTube. All right, what is it? I heard Gus NATO. Anybody else? Everybody agree with that? Gus NATO, because that's right. Yes, that's a Gus NATO. Very good. Sorry, I'm going to have to change the setting on that. All right, so who won? 7 questions, actually, out of 8. Oh, Ron, you only got it to second. I am not going to comment on Ron finishing second. Disappointing. Disappointing. Okay, that was supposed to be fun. All right. Okay, hopefully that was fun. A little humor, see how much you were listening, watching, and then we'll cover some other stuff about that. The first thing we're going to cover after the break here is spotter challenges. And so you'll see it is difficult. It can be hard at times. Those of you that have been spotters before for a long time will know that it's difficult. It's like, okay, I didn't see anything this year, and I'm going to look at it again this year. Or I didn't see anything last year or the previous years. Now I'm going to look at more stuff this year, and eventually you think you're going to get it. I've been doing this for 30 years in the same location. No, you're not going to get it, okay? You're going to see something different. Something's going to change. Something's going to look different than it did in the past, and you're going to scratch your head, and you're going to go, okay, that guy didn't teach this. So what am I looking at now? And we've seen some of that on. So if you think it's hard on the visual side, it's also difficult on the radar side when we're looking at data like that. We learned it in the books. It doesn't look like the book, right? It never is textbook case. When it is, then everybody can figure it out. and knows what it is. But there are times where it's not textbook, and you're like, okay, this doesn't look like what I remember reading or what I've seen before. So it is difficult. So there are challenges, and we're going to cover that. We're also going to cover spotter safety and awareness. Big important stuff right here is the awareness, how to be prepared ahead of time, and then safety. You want to be safe. That's number one. All right, that's number one. If you're going out, you got kids at home, family at home, they want you to come back. So we want you to be, so that you come back safe. And then we'll talk about reporting. That's also very important as well. So these last two sections that we cover here are really important, and pay attention for. So what are some challenges? You know, we want you to take your time when you're out there. We want you to be stationary, because then you can watch, right? Then you can watch it and see what's going on, and you get a really good idea of what is going on. So we want you to be able to do that and provide accurate reports, because accurate reports are important, as we talked about at the very beginning, right? We won't cover that again, but that's really important. So we're going to talk about that. So here's another example, another challenge. Obstructions can be an issue for spotters. Right, you're out there and you're looking at stuff like this one. Is that a tornado? Funnel? Somebody said no, funnel. Well, you can't see the ground. It's on the other side of the trees, right? So it's kind of hard to tell. Still, if you call it in, still pass it on that way, all right? I can see a funnel cloud, but there's trees in the way. I don't know if it's touching the ground. Pass it on that way when you call it in, or send it to us. We'll talk about reporting at the end, but that's the way you pass it on. No debris being lofted yet, but trees are in the way. Probably you can see a clear slot, right? There's a little bit of clear slot. The rear flank downdraft is there. You can see that. So maybe there's a tornado there. Maybe there's one developing. You know, maybe you need to get a better view. Maybe a spotter is on the other side and can see on the other side of the trees and sees that it is a tornado, right? That one did go on to produce a tornado, all right? How about that one? Yes, no? What is scud cloud? Funnel? What is that? Any guesses? Yes. Tornado. Very close. But that's a good answer. But you can't see on the other side of the houses, right? But this storm actually did produce a tornado as it got on the other side, closer to where this photographer was. Can't see the ground again. Don't know if there's any debris, right? Blocked by the homes. Maybe there's other spotters have a better view, but it did produce a weak tornado on the other side. Good answer. Good guess. How about that? Is that a tornado or a funnel cloud? Funnel cloud. I heard funnel cloud over here. Anybody else? Funnel cloud? Somebody said tornado. Why? The debris on the ground ruts above the corn, right? And if you were at this class 3 years ago, yeah, you probably would have said the same thing. We haven't found a good picture to replace this one. Yes, that's actually a tornado on the ground. And yes, that was correct. There is some debris being kicked up right there. See, who took that picture? Is that Jesse that's up there? Yeah. She took that picture from a long way away. There was a tornado. It actually hit a farmstead just to the right of where this stuff started. That was in a cornfield. So, yeah. So there is some debris there. So got to remember, got to look for that. Sometimes you got to look at it. Sometimes hard to see, sometimes not. It was an EF1, very short-lived. Did a number on the corn in both the cornfields that it hit, but yeah, that was a brief tornado. How about that? Well, it's Scud, right? We've already answered the question. But sometimes things look like what they're not, right? So that's not, I think that was in the quiz, wasn't it? Looks kind of like it, yeah. Okay, so scud clouds, they're just low-hanging clouds. They're not rotating. Sometimes they look like they're connected to the base of the cloud, but sometimes they're not. Or sometimes they change a lot and move around. So that's why you want to be stationary while you're watching stuff, okay? Lack of rotation would have been a key for that one. Again, Virga, rain shafts. Now, some might say, I saw this picture. I know who took the picture. She worked for us for a while, but I know who took this picture, and I thought that was a hail shaft, right? Because the white streak, as we discussed earlier, right? But she said, no, it was just rain. I'm like, really? Okay, so like I said, And sometimes we see stuff and we get like, well, what is that? I don't know what that is. But there's that streak. You can kind of see some of those streaks. Virga is one of those things that occurs usually in the summertime or way out in the plains where they're high base storms. As the rain descends, it actually will evaporate because it's too warm, or it's not too warm, but very warm on the surface. So when that rain evaporates, you just get like these little sprinkles that you could dodge if you walked around in the rain. And that's what Virga is. You'll see that on a distance where the rain is actually evaporating before it gets to the ground. But that can confuse people. They think it might be a funnel cloud, developing tornado, stuff like that. Another challenge is sometimes they just don't look like what you think they're supposed to look like, right? Like this one right here is like a big mass of something, and it's like, well, what is this? Mentioned with HP supercells, they get rain shrouded, so sometimes they don't look like your typical textbook tornado, especially if they're very large, wedge tornadoes, that kind of thing. Also, the lighting can be different, bad contrast, like on this one. Could you see it before I threw the lines up there? Yeah, there's actually, let's change the color. Let's change the actual picture, change the tint. Now you can see that there's a tornado there. So sometimes they're hard to see just because of visibility issues, not just because of obstruction, but because of visibility. Also nighttime. I know these tornadoes were a little bit closer to home. December 10th of 21, right? It was 21? Yeah, 21. December 10th to 21. All those storms that went across Arkansas, western Kentucky, western Tennessee, southeast Missouri, northeast Arkansas. This was at night. See how difficult it is to see? So at nighttime, what do you have for visibility? What do you have to light up the sky? Lightning and power flashes. That's it. So if it's out in the country, what do you have? Nothing, right? Nothing. So fortunately for him, he was north of the storm, but he got really good image. Actually, he wasn't north of this. He was east of the storm, and he got a pretty good view. He's right off the Interstate 55, actually. So nighttime is very dangerous, and that's why we tell people just don't go. Yeah, that's what it was actually going on that he couldn't see because of the dark. So nighttime is a big, big challenge. So it's challenging. You're not going to get it on the first day. You're not going to get it on the first year, whatever. Okay, so it takes time. See more. You see more. The more you see, the more you see, the more you see. You build up a database of what things look like, right? And then you get a better idea of when you're going out and so forth. Now let's talk about how to be aware, how to be prepared. Preparedness is probably 75% of the game, so to speak, right? Isn't that what coaches always tell you? Preparedness is a big part of the game. It's all mental or something like that. So being prepared as a spotter is really important. And the reason for that is basically then that way when you go out or you have to be out, all right, maybe this is part of your volunteer duties or job, whatever, and you love going out and spotting. Love that. When you get out there, you know what to expect. Okay, what kind of storms are we getting? All right, that's the kind of storm we're getting. Now I know where I need to be in relation to the storm to see what I need to see. Are we expecting tornadoes? Okay, is it a supercell or a squall line? Okay, I know where to go. Is it hail? Okay, I know where to go. Is it wind? You know, then I know where to go. All right, we're not expecting supercells. Why am I seeing a tornado? Those are the ones that confuse us. Like, we're not expecting tornadoes, and people will call in, hey, I got some tornadoes. I'm like, okay, where? Okay, now are they really seeing it is what we ask, that kind of thing. But you need to be prepared before you go out. Very important. So a little bit about climatology. Our peak tornado season is April to June. Yeah, don't get confused with all the tornadoes we've had in January and December and November over the last 10 years. But our peak season still, since 1950, is April to June. But what do you notice up there? You can get tornadoes any time of the year, right? I mean, granted, we've had November, December, we've had January tornadoes. You get them anytime. If the weather is right, conditions are favorable, you can still get tornadoes. It doesn't matter the time of the year. Look at that. Over the last 10 years, we've had a secondary peak of tornadoes, and that is November and December. So that doesn't include the 9 tornadoes we had in January of this year. But as you can see, there's been kind of a shift to our secondary peak. I don't have an explanation for that. Okay, so don't ask me if it's climate change or global warming or whatever. I don't know. We're just seeing that there's this peak to the cool season with some of our tornadoes. When's the peak time? 3 to 8, 3 p.m. to 8 p.m. All right, and I know for some of you that's like, wait, that's when school gets out. Yeah, it is. Right, it is. That's when school gets out and you're running around, running kids to soccer practice or baseball or softball or something like that. Yeah, that's that time of the day. And it's also partially at night too, which means you can't see them sometimes. All right, but for wind and hail, they're a little bit different. Our wind peak season is May to July, when we actually are warmer during the year. So that occurs in our warmer months. And then our hail season is offset, but it's also in that April to June timeframe like the tornadoes are. The reason the wind peak season is offset a little bit is because you have weaker shear during the summertime. Because the jet stream pushes itself further north during the summer. Remember, our Earth tilts, and so as we get around to the summer months, right, you get sun all day up in Alaska or up in the North Pole, right? But you get weaker shear at that point because the high level jet stream is further to the north. So you don't get those strong wind shear days. Some of our strongest tornadoes that we've had in Illinois over the last 30 years have been in the summer. Summer, early fall maybe. Plainfield was early fall, right before school started. The Roanoke tornado, which was in '04, was in July. Now, Washington was November. We won't go there. So there's some reasons why those seasons shift the way they do, and it's got to do with the wind shear, as we talked about earlier. Now, on average, our area, as you can see there, the higher numbers are in the darker colors, and that is typically, follows I-55 and where the higher populations are located at. So we average about 10 to 13 severe thunderstorm warnings per year in each county. You're like, well, that's not very many. Seems like there's more than that. Well, it's really not that many. It's just, that's what the average is. Some years you get a little more, some years you'll get a little bit less. And then for tornado warnings, we average about 1 to 3 per year. That's it. And you might be thinking to yourself, so what's all the fuss about all these spotter classes when we don't even get that much? Well, it's because it creates a lot of damage, a lot of loss of life and property. And so we want to focus on this, and we need the spotters because the radar can't see what's going on underneath the storm. And that's why we need spotter, to be our eyes of what's going on out there. So, as a spotter, you want to prepare ahead of time. If you're going to be a spotter that goes someplace and sits there and watches from a distance, know your surroundings, right? Know your towers, know the tree lines, the distance, so you can judge the distance between you and the storm that you're looking at. Make sure you do that. Experience has shown us that people usually are about twice as far away as they think they are. I've experienced that too when I've been out with my family with no weather radio, with no phone, and seeing a tornado with a load of groceries in the back. I'm like, hey, let's go look at a tornado. Fine, yeah, wait, whatever, my wife says. And yeah, we saw a tornado. It's like, I had no way to contact the office. I see a tornado. I thought it was like 5-7 miles away. They're like, no, it's 10 to 15 miles away from where you're at. So you do misjudge how far it is. So know your surroundings so that you are familiar with your distance. Have a way to communicate with people ahead of time as well. We all carry around these wonderful inventions, right? Where we can talk to people anywhere and everywhere like they're in the next room, right? And we can get radar on them now too, which is the coolest thing ever. But make sure you have a way of communicating. If you don't have a cell phone, I'm sure, and most of you here probably have a ham radio. That's a way of communicating with, a base station someplace and let them know what's going on. So make sure you have some way of communicating with people when you're out there. Binoculars can be useful if you're looking at a distance. Weather radio, some people will have a weather radio. I know the ham radios have weather radio frequencies already built into them. You can pick up stuff like that, but there are some apps where you can get the weather radio on your phone. Some of them, they don't have all the stations though. Also have a safe shelter. If you're out there, you're stationary, make sure you have a place where you can go if something's coming your way that's going to threaten you, all right? You need to have shelter. And the radar app, there's multiple apps out there. If you want to know which one I use, I'll tell you later. It's very popular, it costs, but it's wonderful. That actually listed some of them actually, so Radar Scope, Weather Radar Pro.
Highly detailed background maps that can show a precise location, like a street intersection, where a radar signature is located. However, with radar data, precise doesn't always mean accurate. Depending on a variety of factors, including distance from the radar, the location of the radar signature may be miles from where the actual weather is occurring. Spotters who interpret the radar information too literally could find themselves in a very dangerous position. You should also remember that in almost every case, the radar image you're looking at is not live and is probably several minutes old. If you don't take this into account, you could end up being caught in a dangerous situation.
So there's definitely a difference between precision and accuracy. So make sure if you're using a radar app on your phone, make sure you see what the time of the image is, so you keep current with what's going on. A lot of times, even with Radar Scope, with the one I use, a lot of times that's still a few minutes old, and I'm looking at the clock, and it's like, okay, it's already a little bit further away than that. So we have a website. If you're not familiar with it, I'm sure most of you probably are. Weather.gov/ILX is our website. We have a lot of great information on there. That's a great way to be prepared ahead of time before you go out, is to look at our website and see what's going on. There's a section at the bottom that shows all those tabs, or all those sections. Skywarn Network, if you click on that, you will see, get some great stuff out of there. Also, the spotter briefing page is something that you can look at every morning, and you can get information off of that. So the spotter briefing page is going to look like this. It's going to show the Storm Prediction Center's day 1, 2, 3, and 4 through 8. Those outlooks. It's going to show that also where you see the bottom images here. That's our county area that we're responsible for. You see that's 35 counties. We go from Galesburg to Lawrenceville, and from Rushville all the way over to the state line. That's the area of our responsibility. All right. Effingham is at a decent distance from the office, but we also have a radar at Evansville over in southwest Indiana that we can use for southeast Illinois as well. Is everybody here from Effingham County? We have anybody outside of Effingham County? If you're outside, raise your hand. Oh, wow, that's a lot. Okay, where are you guys from? Lawrence. Wow, okay. That's 3 hours from the office, yeah. Richland, Shelby, okay. Marion, okay, that's Paducah's area. Thanks for coming, yeah. Madison, that's another Paducah area, I think. No, that's St. Louis, yeah. Yeah. Coles, okay. Fayette County, yeah, that's St. Louis's area. But thanks for coming, that's great. Moultrie, okay. Pike, Clay, okay. All in the area, yeah. I'm familiar with there. Well, I'm glad the other people came from the other other offices areas. That's fine. You can get your training from wherever you want to get it from. You don't have to go to their talks. But anyway, that's the counties we're responsible for. So you see the Storm Prediction Center outlooks are actually zoomed in to just those 35 counties that we're responsible for. So The other offices like St. Louis and Paducah, they do some of the same stuff we do as far as the website. Go to their website and just look at it, and you'll find some of the same information on there that you'll see on ours as well. We also put out what we call a hazardous weather outlook, and that's going to include some spotter information on it at the bottom. Usually it's like, what time are we expecting the storms? Maybe what's the motion of the storms going to be? Okay, that we kind of put that in there so spotters have an idea of what's going on and when we're expecting something, all right? And also inside the section there, the day 1 and then the day 2 through 7, we also talk about, up in here, we also talk about what are we expecting? Tornadoes, hail, wind, you know, that kind of stuff. So that's a place where you can get that information. I already talked about that. This is the Storm Prediction Center outlooks. They have several categories. If you've been around a while, you know that they used to only have 3 categories. Now they have 5. So we'll cover those here. There's regular thunderstorms, which you're not expecting severe weather. Then there's the marginal area, which is a little bit darker green. Maybe some hail, maybe some wind. You know, it's kind of a borderline kind of a case. Typically not expecting tornadoes, but I will say that we've had several marginal cases where we've had tornadoes. So, like low wind, no, we're not expecting anything, 2%. Why am I getting 9 tornadoes? Well, you know, nobody's perfect, and there's things in the environment that we see that sometimes they don't, I would say. But they're good folks. I mean, we coordinate with them. They really hit the high stuff too. Then you have the slight risk is yellow. A few more wind reports, hail reports, maybe a tornado or 2 or something like that, short-lived. It's usually what's expected. Enhanced, you got more storms expected, stronger as well, larger hail, maybe some stronger tornadoes. You know, it just depends. It's always circles, as you see in the image here. This one here, it's also circles around, you know, the higher and higher risks that go up. So the moderate and high risk, now you're talking, you know, major outbreaks, and then the high risk typically are long-lived outbreak tornado events. Derechos are strong wind events as well. Those usually included in stuff like that. You don't see very many high risk anymore. Sometimes they'll throw it in there when they're really, really sure that you're going to get something of that nature. Because there's a lot, you know, you might think severe weather is easy to forecast. It's really not, because there's a lot of points of failure that could occur that could cause things to go around. Okay. So sometimes there's things that can occur to cause the event not to occur, all right? Things that have caused it to fail. And unfortunately, that happens in a lot of our fall cases, our cool season cases when we have tornadoes. Looks like we could have tornadoes, but we're looking at things like, yeah, but if we don't get this, we get nothing. And if we don't get this, we don't get nothing. And we're like waiting and waiting and waiting to see what it's going to do. And it's like, oh, we got this. Oh, okay, now we're going to get them because everything came into place. But there are times, one small thing, and it doesn't happen. So it can be a challenge on our end. We also have weather stories that we put out. If you're familiar with the website, you'll see that on the front page as well. And there's a link on the bottom left where you can click and go see all the different tabs that we have out there. And for severe weather, we usually put things out like where the watch is or the storms, like a radar image showing which direction they're moving, maybe what's expected from individual storms, kind of like to give folks a heads up before we start putting out warnings, kind of that in between the watch and the warning pieces, because we got the watches out, then there's the warning, but there's nothing in between. So we try to fill that gap between those two by putting in weather stories and information out about the radar and what we're seeing and what we're expecting from different sections of the radar. Also on this spotter brief page, there's also places where you could actually click and see the actual warning text, local storm reports. So if you submit something to the ham guys here and they get it to us, and then we put it out, right? And other people will see it as well. You know, and if you live in Lawrence County, your information is really beneficial to Indianapolis out there, you know, Terre Haute in that way. They're always asking us, did you get anything out of this storm? Either yes or no. We need more spotters in our southeast. We really do. because it's a lot of open area, and that information can be passed on to people over in Indiana. So it's really useful if we had more. So there's a lot of other information that you can see on there. So as a spotter, there's no severe weather going on. Go to the page, start looking at when you have some time to get familiar with it, so where you can find stuff, you know, and understand how we have things organized, so that you can look at it like the morning of the possibility, and you can see things ahead of time. I mean, we're watching things several days in advance. You know, as Storm Prediction Center looks at stuff a week in advance, the possibility of maybe severe weather next week, which there is some of that possibility for next Wednesday, I think it is, but that would be further south. But still, everybody's watching stuff, and spotters to do the same. Keep an eye on things going on. You look, oh, nothing concerning, okay, you move on. So let's talk about safety, which is really kind of the biggest thing here for our spotters, is that we want them to be safe. It's your top priority, okay? We want you to do a good job, but we want you to give us good information and accurate information and timely, but we want you to be safe. That's really the biggest thing we want you to do and learn from this. We don't encourage you to be chasers. Now, we have chasers, okay? We have people that do chase, but we don't want you to chase, all right? We've got people that do, and we know them, and some of them are super good, and we've connected with them through Twitter and other means, and we can rely on them. They know what they're looking at, okay? But for those of you that are kind of new to this, we don't want you to go chasing for the thrill of it, okay? We've got plenty of video of people getting too close to a tornado, or getting hit by lightning or wind or whatever. We don't want y'all to do that, okay? Just stay stationary. But if you have to be mobile because of your job, I know fire departments are mobile, EMTs, state police are mobile. We get that. So if you are mobile, make sure you have a safe location of where you're going to go to seek shelter if you need to. And always be aware of rapidly changing conditions, because that occurs all the time. So safe shelter, as I mentioned, is critical, that you need to have a good place to go if you are out, all right? Let's say you're traveling, you're going on vacation or something, and you see something coming. You know, scan the area. Where can I go for safety, for to get away from what's coming? Have a clear path to that that allow you to reach that safely before the storm actually comes. And it needs to be indoors, really. All the safe places always need to be indoors, and that's all for all spotters, whether you're mobile or not. And if you are out there and you're mobile, you know, you need to have safe passageway. You know, it's clear, it's not a dead end, not a muddy road. You know, you can safely get to where you need to go to get to that shelter. We don't want you trapped in like dead ends. And most importantly, emergency vehicles, whether that's police, EMTs, give them the right of way. Give them the right of way, okay? We're not recommending that you cannot put a rotating light on the top of your vehicle if you're not EMT or emergency vehicle. You cannot do that. We've had people do that before, not coming from us. They do it, and then they get in trouble. I'm not telling you now, don't do it, okay? So always remain alert for emergency vehicles that are out there, which means they're going to somebody that's probably injured from maybe what came through. That's more important than you getting your perfect shot, a perfect view of a tornado. Okay? Know your position in respect to the storm and the severe weather part of the storm. Okay? Know your position. Very critical to know that. So that's why sometimes having a radar app on your phone is really important, is because then you know where you are in relation to the storm. And so pick an app that's going to show your GPS location on the radar. I know Radar Scope does that, okay? Then that can help you move away from the strong or the worst part of the storm. Yeah, those places are not the right place to go. You don't want to be in those positions. Never drive through the core of the storm, because you could have big hail, okay, or damaging winds, especially on the backside of that tornado. You don't want this to occur, and you don't want to get into a position where it's like, hey, there's no more rain. Oh, look at that monster in front of me. There's a big, large tornado. That has happened to people before. They come out from the heavy rain, and they're, it's not raining. Oh, and it's up there. You know, the rotation is occurring above them. We've seen those videos before. So you don't want to get caught in that, right? So know your position to the storm itself. So just for an example, position 1 is a good spot for these spotters. That's a good place to be. 2, 3, and 4 really are not good places. That's kind of what it would look like if you were in position 1. And they've got good, safe, good way to get away to the south, to the east and south. Good routes to get away. Position 2, not just the rain, but also the hail. And hail is what? Balls of ice. So it's going to be slick just like ice would, right? So no change there. So you don't want to be in that position either because you might have an accident. Storm might be moving your way, and then you get stuck or trapped or something like that. 3 is not a good spot because, well, it could be lightning, but you're not going to be able to see anything. And isn't that mostly the goal of spotters, is to see something? So you're not going to see anything. And 4, you might be able to see something, but maybe not, right? So 4 is an okay place for safety because, hey, it's moving away from me. I'm not going to get hurt by it. But you might not be able to see anything. Tornado safety is number 1 when it comes to safety because of debris. You don't want to put yourself in a position where that debris is flying all around and it's going to hit you, right? You don't want to do that. We want you to be able to see it. We don't want you to touch it, okay? You don't need to touch it. Do you have to touch a stove to know it's hot when it's on? No, right? So some people learn that way, but we don't want you to touch the tornado because it can hurt you. All right, so we want you to be safe and away from the flying debris and all that kind of stuff because it can create injuries, right? It can go through concrete, asphalt, wow. Go through a house, go through a car, yeah. Those boards can be, yes, they go through stuff like that. Or how about these pictures? That would hurt someone if that hit them. Yeah, and that tornado was just an EF2. So, you know, if you're talking about a 3 or a 4, yeah. And one quick story, my dad did weather as well. He didn't do the weather service, he did the Air Force, but he did weather as well. And he was actually in a tornado when he was younger in Judsonia, Arkansas. And that was so long ago that the safety things that they taught him back then were not what we teach now. And his dad tried to shut the door when the tornado was coming, threw him against the back of the wall, but they tried to leave, and they left the house, which was good, but that was in the middle of the storm, and my dad got hit broadside, fortunately, otherwise I wouldn't be here. He got hit broadside by a piece of sheet metal across his face. So if it had been vertical or horizontal, well, the different outcome would have happened. So we don't want you to, you know, get so close where this kind of stuff is getting too close to you. So that's why we tell you to seek shelter before this kind of stuff starts flying around. Safe shelter. So in, down on the lowest floor, and cover up. We always recommend, they used to recommend you go on the south side of the building because storms only move southwest to northeast. All the debris is going to go one direction and you'll be safe. No, it doesn't work that way anymore. Sometimes the debris goes straight down, you know, it or gets blown around. So it doesn't work that way. But what we is inside a sturdy shelter in the lowest floor possible with as many walls between you and the outside. Think about your house. Think about the structure. What's in the middle of your house? Bathroom, coat closet, maybe linen closet, maybe. No windows. Want you avoid those, right? No. You know, and down low. If you got a basement, good. If not, get to the lowest floor. That's what we recommend. You got to do what's best in your situation and cover up if you can. Bike helmet is okay to wear. If you've got a helmet, that's fine too. I mean, something to cover up with to protect your head. Kind of like the way they're in that picture to the right. If you're in a building, let's say Walmart, where are you going to go at Walmart? You know, that's things that I think about is like, okay, I'm here. We've got severe weather expected. Where do I go? Right? So traveling, the same thing. Where do I go to seek shelter if something's coming my way? So think about that. So think about everybody's got a plan for, you know, like fire escape, right? You should. You plan for your future, like insurance, various things like that, right? You should plan for this as well in case something comes your way. So think about those kind of things with house or wherever you're going. Now, if you're outside, this should be the last resort, is a ditch, right? You should seek sturdy shelter someplace, and usually it's out there somewhere. Farmhouse, if you don't know the people, that's okay. Knock on the door and ask to seek shelter there. But if you're outside, it's coming your way, you got no place else to go, we don't recommend you try outrunning it unless you're really good at knowing where the tornado is, where it's going to go, and you know you can outrun it, okay? Yeah, my dad did that too. We recommend getting in a ditch, getting as low as possible as the last resort. But hopefully you don't have to do that. And we don't recommend you staying in your car. And this is why. Cars don't work well. They don't. So we don't recommend you stay in a car. This is why we don't recommend staying in a car. This person did. And we don't recommend underneath a bridge or an underpass. They really don't work well as good shelter places. He's fortunate, but that was an EF3 that went through back in 2013. Yeah, that's the November 17th. That was the storm that produced the Gifford tornado. He was actually on Interstate 57 south of Champaign where the tornado went through, and he sought shelter underneath the underpass there, underneath a bridge. Fortunately for him, it wasn't strong enough to really hurt him, but you saw all the debris flying around, which could have broken something on the vehicle. All right, so they don't make good shelters. All right, the wind speeds are stronger underneath there. The debris gets funneled in and kind of gets stuck in some of the crevices. And each underpass that you see is not the same. They're not all built the same. There's not girders up underneath there you can hang on to and grab a hold and ride it out. Sometimes it's just concrete butted up against concrete. It's not a good place to go. Flooding can be an issue too, so let's not just, don't forget about the flooding. I mean, there's tornadoes, hail, and wind, but there's also flooding. You know, flood is a flash flood when water rises rapidly, either from a creek or a stream or maybe a river, right? Can occur in any area if the ground, especially if the ground is moist or if the ground is frozen. In the wintertime, toward the spring, the end of the winter into the spring, not right now because none of the rivers are frozen, but anyway, none of the ground's frozen either. But when we have frozen ground and we get a lot of rain, it turns into runoff really quickly, and then you can get flooding from that. In cities and areas, know your cities that have the underpasses. I know Effingham has a few underpasses that probably easily flood, right? Every city has that as well. Champaign, Decatur, they've all got it. That's a picture indicator from early last year when they had some flooding underneath the railroad tracks there. So 1 to 2 inches of rainfall in about 60 minutes or less is a good guideline on if you're going to get some flash flooding from that. If there's any dam or levee failures, that creates flash flooding as well. And now some of you are going to say, well, I drive across this road all the time. I drive down this road. I know where it's low. I know how deep that is. I know it's 7 o'clock at night. I can't see, but I know how deep it is. Yeah, but you don't know what's there. Is the road still there? And in this situation, the road gets washed away in some of those. You know, and one of those, with the truck on the right, that's in Illinois. So you see creek rose and washed the road out, and he didn't see it. Again, probably thought that it's always there. But never cross a water-covered road or bridge in a vehicle. We don't want you walking across the roads either, unless you're evacuating, because sometimes you don't know what's in that water. Could be pretty dirty. What we'd rather see you do is turn around, don't drown. That's the catchphrase that we have for safety from flooding. Turn around, don't drown. If you're headed to work, call your boss, say, hey, I'm going to be late. The road's flooded here. I got to go a different way. Rather be safe than be stuck, and rather be safe than force somebody else to come get you out of the flood, right? Because that's what's going to happen. One of the greatest dangers to spotters is lightning, because you're out in the open. You're out in the open. So we want you to stay indoors, or if you're in a vehicle, stay in your vehicle. Hopefully it's not fiberglass, like a Corvette, but I wouldn't take a Corvette out for storm chasing. And it's not convertible either. That'll be good. But as you can see, lightning will strike objects real close. Yes, our videos are family friendly. So you saw what happened with this one. What did you notice in this video and the previous? What did you notice? Something was missing. What was missing in those two videos? Yes, there was no rain. It was not raining in either one of those. It doesn't have to be raining for you to get lightning. Probably no trees like that in Illinois, but okay. There was no rain, so you can get lightning outside the thunderstorm, sometimes up to 10 miles away. Right? Up to 10 miles away. So lightning, again, is the greatest threat to a spotter. So where are the safe locations? Secure buildings, away from windows and doors. How many of you like to watch thunderstorms? Come on. Oh, I think every hand should be. Yes. I do too. I get bored in the wintertime when it's snowing. I don't like the snow. I like the lightning and the thunder. I'm like, yeah, you know. Okay, good. It's severe weather season again. I think my age is getting to me when I don't want to see severe weather. But anyway, but we want you to say, what do? We go up to the window, right? We go outside. Want to watch? Cool. Wow, look at that. And what do we say in safety? Stay away from windows and doors. Dang it. You know, so yeah, we know people are going to want to look because it excites people. People like to look at weather. We get it. We're the same way. Why do you think I do what I do, right? But we still want you to be safe, away from windows and doors. And we're going to say that with hail and wind as well. Inside, sturdy shelter, away from windows and doors. Period. All right. If you're outside in a vehicle, yeah, you want to stay away. You want to be aware that lightning could occur under the storm, in the storm, or even up to 10 miles away from the storm, all right? So if you're in a vehicle, stay inside. Keep the windows rolled up, all right? So wind safety. If you're in a vehicle, don't park underneath trees, power lines, power poles next to them, anything like that. You don't want your car to look like that car, right? And you don't want to be in that car when that comes down. It has happened with people driving around in a town, in a city, and a tree falls on a car while they're driving it. So if you do have to go somewhere, park, pull away from trees, power lines, that kind of stuff.
Wait it out.
Especially for wind.
Right here. Isn't it something This is cool, man.
Better to pull over and just wait.
There's always one. There's always one.
Whoa. You're gonna go front?
Yeah. So notice what these guys did. Now these are
Look at that.
professionals. Wind 60, 80 miles an hour. I think this was a rear flank downdraft. I'm not sure. It might have been
It's here.
HP Supercell, maybe. I don't know. But the vehicle, he pointed it parallel to the wind. Right? Less surface area for the wind to hit it and tip it over. So as you know from just regular wind, high-profile vehicles can get buoyed around a lot, right? Whether that's an SUV or a semi, right? So, and we get some strong winds in Illinois. So when thunderstorm winds come in like this, we want you to be safe as well. So if you're out and you get stuck in it, you want to be parallel to the wind, less of a surface area. Whether you're back into it or your engine in, front into it, I don't know. Don't think it really matters as long as you're parallel to the wind and not perpendicular to it. And they were smart and they did that. They knew what they were doing. Thunderstorm winds can do a lot of stuff. Here's a power line, a power pole with a transformer that was dropped into a mobile home. There's this was in Leroy last year. There's a tree. That's kind of hard to figure out what's going on, but there's a tree through the roof of a mobile home. So, mobile homes are not sturdy or safe shelters. If you live in a mobile home, we know some people do, but if you live in a mobile home, we recommend that you have someplace else to go. If it's a mobile home park, hopefully they have like a community building that's sturdy, or maybe you have a friend that lives in town that will let you use their basement if a storm is coming their way. So just be aware of that when it comes to, again, stay away from doors, windows, and upper levels. We say that all the time. Hail's the same way. Stay inside. What happened to my hail slide? Okay. So how do you report? All right, we've gone through last thing. How do you report? We don't want you to keep it to yourself. We want you to tell someone. All right, Effingham County is, talk to this guy back here on the ham radio. However, we have ways of you communicating this information to us. It's not through a ham. All right, we do. So don't worry. So when reporting on features not located right where you are, please give us a direction and an estimated distance from where you're located at. All right. Sometimes we'll get reports like, oh, I see a tornado 5 miles west of Effingham. Great. There's a lot of ground 5 miles west of Effingham. All right. There's a lot of ground out there. So be a little bit more specific than that. So you want to look for that. Spotter, let's say like this example here. Spotters near Poplar City. Do not, there's a tornado in Poplar City. No, it's outside of Poplar City. It'd be better if I'm near Poplar City, I see a tornado in the distance in the west. All right, that's what you want to report. That's a better report. A really good report would be this. I'm near Poplar City. I see a tornado about 8 to 10 miles away from me to my west. That's a better report because now you're giving me a distance, right? That's kind of, but this individual has radar with them and they can be more specific. And I remember this day, there were people that were over across on the east side of the Illinois River looking at tornadoes that were on the west side of the river, and they thought they were on the east side of the river. They thought the tornadoes were closer to them than what they really were. All right, so be aware of that. So make an accurate report. So what do you report? Tornadoes, funnel clouds, wall clouds. All right, funnel clouds do not touch the ground. Don't call in and say, hey, I got a funnel cloud on the ground. No, you have a tornado. If funnel cloud's on the ground, it is a tornado, okay? Wall cloud, is it rotating? How long has it been there? That kind of thing. If it spins, call it in, right? That's what we want to know. Flooding, how deep is the water? Is the water flowing or is it stationary? What roads are impacted? All that information is useful. Is it in a rural area? Is it in a city? Is there any damage? Is there cars stranded? Are they doing water rescues? That's important. Water rescues are important to us. We need to know that. That's an emergency. If it's flooding and you can't drive through the intersection because the drains are clogged, okay, go slow, whatever. But there's water rescues, that's worse. We need to know that. Wind reports. Do your best to estimate the wind if you can. If you can't, just tell us what you see. I've got twigs down. I've got large branches down. All right. Is the tree old? Is the tree new? If you see trees down, is it old or new? That's important to the age of the tree if you can tell. Sometimes what type of tree is important to us. Is there power lines? Hail. All right. Now, I know not everyone here carries a ruler in their car or in their pocket. Okay. So, but some people, well, maybe some people, don't you keep loose change in your car still? Even though we use our cards for everything else? Right? You probably have some loose change, right? Aldi, you have a quarter. If you go to Aldi, you have to have a quarter, right? So you always have a quarter in your car. My wife does. So, but yeah, you carry the stuff around and estimate the hail size. We need to know that. And the handout that's on the table in the back outside has some ways of estimating and has some information in regards to this and also the wind. So you don't have to try to remember this. When you call, tell us who you are. You're a trained. You can tell us which class you went to if you wanted to. Keeps dropping out. Okay. But tell us your trained spotter, what you witnessed specifically, the specific weather event that you saw. Okay, when the event occurred, the time that it occurred, and then also your location. All right, sorry, where the event occurred. Not so much that it occurred where you're at, but if you're where you're at and the distance it was from you, right, in the direction, that's more helpful. Who do you report to? Okay, as we've talked about already, you want to talk to if you got a ham, you're part of the Aries Club here, you call them. If you're not, you have some other ways of doing it. You can call the emergency manager of the county, right? For Effingham, you can call her. For the other counties, I'm not sure about, you said Fayette County, right? I'm not sure about Fayette County. I'm not sure who the emergency manager is, but I'm guessing that that's who you would report to. If you don't know, try to look them up, find them, and then ask, who do I report to? All right, for those other counties as well. 911 is a good option, especially if there's injuries, because that's more important than getting the information to us. That's if there's injuries, you contact someone first about that. Take care of that, then get the information to us, okay? And some of our websites do have ways where you can report to. Now, those of you who are not part of HAMS or part of EMA, there is something called Skywarn Network, which I think there's some bumper stickers and stuff, car thing, magnets that are going to be distributed later today in regards to that. We do on our website, on our spotter website, there is a Skywarn logo. You can click on that and you can actually register as a Skywarn spotter. That information will come to us into a spreadsheet and we'll get it. We don't share your information with FBI or CIA or anybody like that, okay? So it's safe. It's a national organization that's recognized just about everywhere in the country, but you can sign up for that and then you'll have a way of contacting us. There's other ways as well. So like I said, 911, if there's any injuries. Here's some other ways of getting the information to us. And I know for those of you outside of our area, those others, offices like Paducah and St. Louis have the same thing. They do have the same thing. So there's email. Ours is ilxspotter@noaa.gov. All right. There's Facebook. There's Twitter. We follow Twitter. We've always got somebody following Twitter and monitoring Facebook. There is an online way, which there's the link right there up there on the slide. There is a link that does work. That does work. And then there's a way you can text us. If you've got a picture that you need to get to us in a hurry, hey, I got a tornado, I want to send you a picture. And it needs to be an active event or one that just occurred. So nothing from like a year ago. We don't want to see that. We've got lots of them already. But if it's a current event going on, that is an iPhone. Just text us the picture, we'll get it. We're starting to use, this is a new thing this year we're going to start to do and try to use that and to see if that works for us. You can say, hey, I'm a Skywarn spotter or I'm a train spotter. I went to the Effingham class. This guy yammered for 3 hours, okay? No, you don't have to tell them that because they'll know who it is. But you can tell them that, something. And then we'll get the information. If you're outside of our area and you contact us, we will provide that information to the other office. We'll send it to Paducah. We'll send it to St. Louis. We'll send it to Indy if we need to, right? So we will pass that information on. We get it all the time. Hey, I got a spotter from your area and he's up here in Quad Cities area. It's like, oh, okay. Various things like that. So there's ways to get that information to us. Some of these options are on that handout that's out there on the table as well. You don't necessarily have to remember everything. All right, so ham radio, the Mount Pulaski repeater is 145.390, but you said you can't reach that. Okay, what did you say Shelbyville was? Yeah, there's a Shelbyville repeater. It's actually Tower Hill. Yeah. 1736. Oh, 147.36. Okay, I didn't know there was another one there. Over the last several years, because of COVID, we have not had ham operators in our office. We typically have 2 in our office for every severe weather event we have. We bring them in because they can help reach people. We've got a great network that's north of Lincoln. Unfortunately, it's in Peoria, Bloomington, up around there. Covers kind of Menard County, Sangamon a little bit. But after we get down toward eastern Illinois and southeast, we don't have a lot of ham connections, so we have to use the repeater. But that's the one in Mount Pulaski that we're aware of. And again, the one at Tower Hill is the other one that can be used for here. We need to work on that, try to get that finalized. But if you don't have a ham license, then yeah, you can call us. You can send it to us on Facebook or Twitter. There's other ways to get the information to us. So a few final words. Keep yourself safe. If you're not safe, you can't help us, and you can't help anybody else, right? So in my 30 years of being in Central Illinois, I know of one person that had a major injury from spotting. But he did what he could when the tornado was coming and got into the basement, but yet the tornado just kind of mixed everything up and dropped it into the basement, and he broke his hip or leg or something, like a couple things like that. He survived, but he was pretty badly hurt. Other than that, I've never heard of a spotter or chaser getting injured. In Illinois, doesn't count the other areas of the country. So we want you to be safe. It's vital. Your reports, accurate and timely reports, again, are vital to the process. It helps us making a good decision, either to keep a warning going, to issue another warning, and also it is important to the people downstream from you, in your community and in the communities, downstream where the storm is headed. So we all need those reports, and you guys are vital to that process. If we have an event and you're out and about and they see something that storm damage from the previous event and it's a couple days later, you can always call it in and say, hey, I've got this, I've got that. That can be helpful too. Don't think that somebody else, oh, they already got it reported. No, that's typically not the case. Most people, if they have storm damage, let's say they have a big branch that falls in their yard, it doesn't hit anything, what are they going to do? Clean it up? They're going to tell anybody? No, unless it's the neighbor, their kids or something. They'll let them know. Do they call 911 or call the emergency manager? Nope. They can't do anything for them. A lot of the damage that occurs never gets reported to us because people are like, I just got to clean it up. Like the Amish, okay, up in, further north of here, Amish. They go out there, they clean stuff up, they rebuild stuff, nobody knows except for them. So there's a lot of times stuff occurs. Tree damage to us is important, but to most people, it's not, unless it actually the branch falls on something. So just be aware of that. If there's tornadoes that go through, we like to know where it started and where it ended and how strong it was along the way. We file those kind of reports and do those damage surveys for that. Okay, and sometimes, well, it went through a tree grove over there, but nobody cares because nobody is affected by it. But sometimes we like to know. So if you see something that might be useful and think it could have occurred from a storm you saw a couple days ago, it's not wrong to go ahead and call it in. Don't get overwhelmed. There's a lot that has been covered, from how storms develop, what's required, what kind of storms, that kind of thing, tornadoes, hail, wind, safety, again, number one, how to report, all that kind of stuff. There's a lot of information there, and don't think you're just going to get it on the first time. You're going to get out there and see stuff, and you're going to go, I think this is what he's talking about. I'm not sure. That's okay. Always go out with somebody experienced if you can, until you get more comfortable doing it. Like I said, 30 years, I've seen some weird stuff as well that has occurred in the past. But it comes with time, with experience. We recommend that you take this class at least once every 2 years, maybe once every 3 years. I mean, COVID kind of set us back with a few of that, but that's okay. We understand. We actually did it online in 2021, which was kind of successful at the time. But last year, online was not successful. There's also segments of this training, not so much this one, but ones we've done in the past on our spotter briefing page on that website. where you can go back and get additional information that maybe you want to refresh, an update, or maybe there's a different way somebody else talked about it and it makes it easier to understand. So at this point, I'm done. We want you to be safe out there. There's a few of those links. Again, there's handouts on my table out there that you can get, because we're going to be breaking here in a minute. I think Russ wants to say something before we get going, but appreciate you for being here today. And if you got any questions, I'll be around to answer any of those. So thank you very much. I'm done for this round.
Thank you for coming. Just want to let you know that this event is actually live streamed. So if you want to watch the archive, go to YouTube, National Trail Amateur Radio Club, NTARC Club, and it should be able to find the information on that.
By the way, the young lady over here that's doing the closed captioning, isn't that fascinating? It's amazing. She does a great job. She's also my daughter. So thank you, Catherine. Really appreciate doing this. I've been watching it a little bit on live stream, and it is really, really interesting on live stream, seeing and hearing it all. Before you leave, come up here to we've got some special stuff for the people that go through the weather spotting class. And also, we're going to switch rooms, we think, for this afternoon. We're going to be doing weather spotting over in that room and the general sessions over here because of the live streaming. Be too much of a hassle trying to move all the equipment. So this afternoon, if your friends are coming, you leave here today, give them a call, tell them to come in. I'm sure you found everything here really, really interesting. So once again, thank you for coming. I hope to see you this afternoon. And we'll have some more stuff going on. We have...
Yeah, real quick. Big round of applause for Russ, too. He's the one that really spearheaded this and put this all together. So big thanks to him. On behalf of the National Trail Amateur Radio Club, I do want to present this award to Mr. Otten here for giving the presentation. He did, I think, a fantastic job. So, again, another big round of applause for him. So, here you go. So... Cool. Yep. There's the calendar. Got it. Cool. So, yep. There you go.
Come up around here and we'll get you the... Come on up here and we'll get you the...